pick back up where we left off from the last video, where we were expanding single logarithms into sums and differences. Now what we're going to do is we're going to kind of condense sums and differences of log expressions into a single logarithmic expression using the properties of logarithms first discussed in the last video, and also mentioned that it's sometimes called the laws of logarithms. So the directions are: write the expression as a single logarithm and simplify the result if possible. You know how you can tell if a logarithm is a single logarithm? It's happy. Alright, so now I'm going to take each one of these expressions and I'm going to use the power property first by rewriting this as the log of x to the third power minus the log of y to the 1/3 power minus the log of z to the 2/3 power. Now I'm going to go from left to right. I'm going to write this, since we have a difference of the logarithms, as a quotient using the second property, log, these are common logs, of x to the third divided by y to the 1/3. And then I'm going to go one extra step and take this difference here and write this as a quotient. So this is the log of x to the third, y to the 1/3, divided by all of that by z to the 2/3, which is the log of x to the third, y to the 1/3. When you're dividing, you invert and multiply times 1 over z to the 2/3, like that. And I'm going to write this as the log of x to the third on top, and on the bottom I have y to the 1/3, I have z to the 1/3, that's a cube root, that's a cube root. I'm going to write this as the cube root of the product, which would be y times z squared, because this is to the 2/3. Y times z squared. Now, again, you may think, well, I shouldn't leave a radical there, I should multiply top and bottom by the cube root of y squared z. I think we're fine here for this particular kind of problem. And that's my answer. One more example like this with some natural logs. Works the same way, using the same properties, but we have a slightly different simplification here. I'm going to write this as the natural log of t to the 1/3 using the product, or the power property. After you do a couple of these, you can combine steps. I'm just going one at a time. Now that's the sum is a product. This is the natural log of t to the 1/3 times t squared minus 9. Now if you're wondering, should I distribute through? No, not yet. And you might already know why, because you can see that that's going to refer to a division, and if we divide here, it's going to simplify. I'm going to write this as the natural log of t to the 1/3 times the quantity t squared minus 9, all of that divided by t minus 3, which is the natural log of t to the 1/3. Remember, this is t minus 3, t plus 3, all over t minus 3. Taking the natural log of all that, and you can see these will simplify a little bit. And I have the natural log of t to the 1/3 times the quantity t plus 3. Now, at this point, you could probably leave it like this if you rewrote it as the natural log of the quantity t to the 4/3 plus 3t to the 1/3. I don't see a big advantage there. You could probably leave this in either form and be just fine. Of course, if you're doing multiple choice, you're going to want to know that this is equivalent to this, just in case one form or the other is listed. This last example here on this part is a little bit different in that we're not given a variable expression, logarithmic expression, but we have a number. Okay, so it says given that the log base b of 2 is approximately 0.356 and the log base b of 3, notice the same base b, of 3 is approximately 0.565, we are to approximate the value of the log base b of 24. Now you say, well, I don't know what logarithm it is. Is it base 10? Is it base e? Is it base 5? We're going to use this and a little bit about what we know about numbers. I hope you will agree that log base b of 24 can be thought of as 8 times 3, or even better, 2 to the third times 3. Now I rewrote it like that because I have some information about log base b of 2 and I have some information about log base b of 3. I'm going to break this apart using the product property and write this as the log base b of 2 to the third power plus the log base b of 3. I'm going to write this as, using the power property, 3 times log base b of 2 plus log base b of 3, which is going to be approximately 3 times 0.356 plus approximately, what was it? There it is, 0.565. Oops, that's a decimal point right there. Okay, and if you do the arithmetic here, I believe you're going to get 1.633. Okay, now, because we don't know the base, we have to use the idea of what we were talking about expanding, so that we can use these two logarithms. There's some pretty challenging problems that arise doing this style of problem.